afternoon talking about equivalent fractions. Now, we have a couple of videos that are literally uploading as we speak. We have a basic intro to fractions coming, as well as a types of fractions video too. So as that starts to upload, don't worry. If you start watching this one and you're like, oh, I don't really know what she's talking about, don't worry. Feel free to look at those videos first. This is the third one about fractions. We're going to kind of go in order here, start talking about fractions, making some videos about that. Fractions is pretty heavy. So, and I say in the intro video, don't get scared because fractions can be a little bit scary, but we do see them in everyday life. So we're going to make sure that they are understood and that they're important for us to understand in our everyday life. So welcome if you've just joined us. If it's the first time you're joining us, hello, so glad you found us. If it's not your first time, well, great, glad to have you back. So starting about equivalent fractions here, let's go. So we're remembering that equivalent fractions, it has a little hint in there. Equivalent fractions means equal. And we're making sure that these fractions are going to have the same value. So for example here, let's start with a fraction that everybody knows. Pretend that is as equal as we can get it. Remember in our sketches, we can be a little off, but as long as we're not drawing the line over here and making it look weird, that's okay. Color this part in best I can. There we go. So we got 1/2. I hope you realize that. 1/2 is our fraction here. So it's really important in equivalent fractions that we're not actually going to color in any more or any extra of this. The fraction itself is going to remain the same in the sense that it's still going to be equal. It's still going to be the same value. However, it's we're just going to represent it in different ways. So if this is 1/2, we can say, well, let's make a couple of cuts of this rectangle. So instead of having 2 pieces and one of them colored in, I now have 4 pieces and 2 of them colored in. So I can say this time that 2/4 or 2/4 is equivalent to 1/2. 2 is half of 4. We can go further and cut it a little bit more. So now we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 pieces. Notice, of course, that along with the other videos, I'm putting the 8 at the bottom because that's the denominator. That's how many pieces are in the whole. And then there are 1, 2, 3, 4 colored in. There we go. Now, of course, you probably didn't even have to count that 4, right? Because you know that half of 8 is 4. Okay, let's keep going. So this is all equal. I'm going to cut it again. Should I leave it like that? No, definitely not. Because remember, fractions have to be equal, right? Equal in the sense of all of the pieces need to be equal. Now, again, this is a sketch, right? If I was using the computer or something, if I was doing this in a worksheet or in my workbook or something for math, then obviously it would be perfect. But because it's just a sketch, just to help us visualize and to understand, it makes sense like this. So 1, 2, 3, 4, 5, 6, 7, 8 times 2, that's 16. I'm not going to even count the part that's colored. You know that half of 16 is 8. So as you can probably guess, I can literally go on forever right now. I could keep cutting and adding these lines, and then I will have a whole bunch of different equivalent fractions or fractions that are the same value. That's why we're talking about equivalent fractions, that there exists an infinite number of possibilities. So no matter what you do, it's always, as long as it's the same, you'll have equivalent fractions. Let me give you more examples. So that was with 1/2. As another visual here are some fraction strips. So I want you to imagine that this is the whole. Thank you so much, Gina. So here I am. So we have the 1/2 and 1/2 that represents the whole here. So I'm going to leave this here just for the visual, and I'm just going to focus on my 1/2 here again. So I'm looking for something that's going to be exactly the same as that. So no matter what it is, as long as it's half of the representation of the whole, we can try it out. So let's go with 6 sixths. 1, 2, 3. Exactly the same. So I can say that 3/6 is equivalent to 1/2 because 3 is half of 6. So half is the most obvious one, of course. And there's exists, like I said, a million infinite option for different opportunities here. I'm so glad you find it helpful. So we have, let's look at another example. Let's look at, let's go with 2/3 here. All right, so this is 2/3, 1, 2, okay. Looking for other possibilities for this. So let's write 2/3 on the side here. Let's try tenths. See if I can build this up here. I don't know. What are you thinking? Oh, missing a little bit here. So you're probably going to have a rule somewhere in here. Yeah, definitely. So sometimes it's not going to work. So especially when dealing with fraction strips like this, you'll see that there's going to be eventual multiples that will help, of course, in our equivalent fractions. Face reveal. No, that's not important. Just the math. So let's try 6. Because I know that 3, 6, 9, etc. will probably work. That makes more sense. There we go. So 2/3 is the same thing as 1, 2, 3, 4 sixths. Okay, let's look at some other examples. So let's say, for example, your teacher said, all right, I'm going to give you a fraction, say 3/10, 3/10. And I want you to find any equivalent fraction that you can that will be the same value as 3/10. Well, in this case, you can literally do whatever you want. But the rule is that whatever you want has to be the same on the bottom and on the top. So when it comes to fractions, usually we deal with multiplication and division, okay? So whatever you multiply, kind of like what we did up here, right? We multiply, we made the number bigger. That whatever happens on the top has to happen on the bottom as well. So we have, let's say, times 2. Great. I'm going to do the same thing down here. Oh, there we go. That's a great example. We have, coming up here, we have another example of another equivalent fraction for this. I'm going to absolutely get to that. So I like to start with times 2 just because it's the easiest one to do. And of course, times 10 is definitely easy as well. We got 3 times 2, which is 6. 10 times 2, which is 20. 6/20 is equivalent to 3/10 because I literally just did the same thing. Hi, thanks for joining. So we had another example in our comments. Absolutely, that 3/10 is equivalent to 30 out of 100. All right, let's prove that. Well, all we have to do is, again, what did I do to 3 to get to 30? Well, I just multiplied by 10. And whatever I do up here, I have to do down here as well. I can't just randomly decide to change the number. 10 times 10 is 100. Same thing, same thing. 30 over 100, or 30 hundredths, is equivalent to 3/10. Great, 15 out of 50 would also be perfect as well. 3 times 5 is 15. 10 times 5 is 50. Great. So you see there's so many possibilities. We can fill up the comment sections with all of these examples, but you're absolutely right. You can also work the other way, right? You can keep dividing or you can multiply. So multiplication, division are the main ones here. Okay, let's say I have another example, 5 over 11, or 5/11ths. Sounds a bit weird, but so 5 over 11, give me any equivalent fraction for that. I'm going to do, let's see, I'm going to multiply this by 100 and multiply this by 50. No, of course I can't do that. It's not the same. To make it equivalent or equal, it has to be the same number. So I'm going to keep that 100, and 500 out of 1100, of course, is equivalent to 5 out of 11. Okay, and of course works with improper fractions as well. We can do 20 out of 40. Say, okay, give me an equivalent fraction for 20 out of 40. Well, I could make this fraction bigger if I want. I could make it smaller as long as it's the same thing, right? So in this case, I think I'm going to make it smaller. Perfect, 1/2. You already caught that. We know that 20 is half of 40, so of course. So I'm going to say, let's say I'm going to divide this by 10. I'm going to divide this by 10. It's the same thing. 20 divided by 10 is 2. 40 divided by 10 is 4. 2/4. We could even get smaller and do 1/2. Nice and simple. Okay, so we can, if you're a teacher or you're given the example of just create any equivalent fraction you want, you can literally pick from anything. Makes life a lot easier. Let me erase a little bit. However, sometimes you're going to have it pre-set up for you, so that you're going to have to find out what is the actual number they picked to divide or multiply by. So for example, I'm going to use that 3/10 again. Here's our equal sign, of course, in between. And let's say there's a missing number up here and 30 down here. So they want to know. Thank you so much, Star Sparkles. I so appreciate your lovely comments. Glad I could help. Okay, so we're trying to figure out here now what is going to be the missing number. So this case, if it just said, okay, find any equivalent fraction, we can find any number we want to multiply or divide if the division works in this case. So we're going to figure out, what do I need to do? Well, 3 and nothing, that's not going to help me. I always have to start with the one that has the most information. So what do I have to do to 10 to get 30? 10 times something is 30. Yeah, 10 times 30. And this is going to help me because now I know whatever I'm doing to the bottom, I have to do to the top. So 10 times 3 is 30. This has to be times 3 as well. 3 times 3 is 9. Beautiful. There's our missing number. So sometimes they have more control over it when you're asking these types of questions because they want to have a specific example of an equivalent fraction in this case. But it's always going to work the same way as long as you use the same numbers. I'm just going to color this in. This is bothering me. Okay, so let's look at another example just like this to see how it would fit in. Let's try 3/8 is something, 27 out of something. So this time the denominator is missing, but that really doesn't matter because we're going to do the same trick. So in this case, we can't actually start on the bottom like we did up here, right? Because that doesn't have any information. So 8 times something is nothing. No, that doesn't help. So we're going to ignore the bottom for now. We're just going to focus on the top. So what do I have to do to 3 to get 27? So 3 times something is 27, or 27 divided by something is 3. You can go the other way. Remember, we're only using multiplication and division. It won't work, of course, with subtraction and addition. In this case, we can't do 27 minus whatever is 3. No, that doesn't work. Some people are commenting about counting money. I would actually, but I've noticed that in the corner, a lot of people have found us from different parts of the world and different money in that case. So that might be a little bit complicated, but for now, we'll focus on fractions. So what do I have to do to 3 to get 27? 3 times 9. That's it. Okay, so 3 times 9 is 27. Again, same thing here. 3 times 9 down here. 8 times 9 is 72. So 27/72 is equivalent to 3/8. They have the same value. So I'm going to do 2 more examples to show you what you would do when there's empty spaces on the other side. It's going to be the same thing. I'm going to pre-set these up for us. So I'm going to separate it a little bit. Let's try 3/something and yeah, 15 out of 60. Yeah, and then figure out what the missing thing is there. Absolutely. Let's try 48 out of 66. When I write the other one, people could try to figure out what that one is. I'll squeeze into my corner here. Thanks so much. We'll see you soon. Thanks for joining. I'm almost done. All right, so we have something out of 11 equals 48 out of 66. Okay, so again, make your life very simple. You'll notice here probably that multiplication and division tables really do help. If you still don't know those, it's really important to practice. Lots of flashcard practice is available online too, so go for it, okay? Can't figure out the top, there's not enough information, I'm going to go to the bottom. What do I have to do to 11 to get 66? Times 6 times 6. Same thing. Something times 6 is 48. If I want to go the opposite way, 48 divided by 6 is 8. There we go. Nice and quick. Same thing down here. Oh, not enough information on the bottom. I'm going to go to the top. 3 times something is 12. 3 times 4 is 12. Something times 4 is 16, or 16 divided by 4 is 4. There we go. That's how equivalent fractions work. And equivalent fractions are going to come up a lot in our use with fractions. There is a video that I already have posted about how they really do help with word problems. So more details to follow on that. But this is the basic intro for it. I really hope it helped. Thank you for people who joined me live this afternoon. And I hope to see you again soon. Please don't forget to like, subscribe, and let me know if there's any other videos you would like to see. Thanks so much. See you soon.